Hey, welcome. So, every single day, we're surrounded by devices that honestly feel a little bit like magic, right? Your phone, your laptop, even your watch, they just work. But here's the secret: it isn't magic at all. It's brilliant engineering, and today, we're going to pull back that curtain and take a peek into the hidden world that powers literally every piece of tech you use. So, let's dive in. I mean, just think about it for a second. You're looking at a screen, you're hearing my voice. Billions, and I mean billions, of calculations are happening every single second just to make that possible. So the big question is, how? How does a chunk of metal and silicon actually know what to do? How does it all come together? Well, the answer starts with a plan. A kind of master plan that lays out exactly how every computer, from a massive supercomputer all the way down to the tiny chip in your coffee maker, is built from the ground up. You can think of it as the digital blueprint. And that blueprint has a proper name. It's called computer architecture. It's basically the fundamental rulebook for how a computer system works. It describes its function, its organization, and how it's all put together. It's really the crucial bridge between the physical hardware, the actual silicon and wires, and the software that makes it do amazing things. Yeah, this blueprint analogy really hits the nail on the head. You know how a house blueprint shows where the walls go, where the pipes run, where the electrical outlets are? Well, computer architecture does the exact same thing, but for a processor's components. And here's the wild part. Every tiny decision made in that blueprint has massive consequences you feel every day. One choice might give your phone incredible battery life, but a different choice could make your gaming PC unbelievably fast. Without this blueprint, a computer would just be, a really expensive paperweight. So you might be wondering, how on earth do engineers even begin to create something so complex? Well, the whole field really stands on a solid foundation made of three core pillars. Let's break them down. First up, pillar number one, you gotta understand the basics. This is like the ultimate Lego set for computing. We're talking about the fundamental building blocks, things like digital circuits and logic gates. These are just teeny tiny microscopic switches that can either be on or off, a 1 or a 0. That's it. But when you combine millions of them in clever ways, that's when you can start doing math and storing information. Seriously, everything starts right here. Okay, so you've got your box of Legos. Now what? Pillar 2 is all about understanding the principles. See, you can have a mountain of Lego bricks, but without instructions or a plan, you're not building a spaceship. You're just making a colorful mess. These principles are the key design rules that architects use to build systems that are powerful, efficient, and reliable. A great example is a concept called pipelining, which is kind of like an assembly line for calculations, letting the processor work on multiple things at once. This is where the strategy really comes into play. And the final pillar? Understanding the precedents. You've got to know your history. Look, nobody invents this stuff from scratch in a vacuum. Architects are constantly studying the history of computing. They look at the huge successes and the spectacular failures to learn what works and what doesn't. For example, those incredibly efficient chips running our smartphones today, their design DNA can be traced directly back to low-power designs pioneered way back in the 80s. It's the perfect example of how innovation means standing on the shoulders of giants. So, having all this knowledge is one thing, but the real excitement, the part where it gets fun, is turning all that theory into a reality. This is where the computer architect gets to be both an artist and an engineer, taking those three pillars and using them to create something completely new. And this journey from idea to actual innovation is fascinating. It all starts with evaluating trade-offs, which is a constant balancing act. Let's say you're designing a gaming laptop. You'll probably trade some power efficiency for raw, unadulterated speed. But for a smartwatch, you do the exact opposite. You're prioritizing battery life above all else. Then you actually implement the design. You build a real system, and spoiler alert, it almost never works right the first time. So then you have to go on a bug hunt. But all of this, the trade-offs, the building, the fixing, it's all in service of that final step, developing novel ideas that push all of technology forward. Which, of course, brings us to the most important question of all. Why does any of this matter? Why should you care? Well, it matters because these principles aren't just about the computers we have today. They are actively being used to architect the future. This right here, this is the whole point. The reason for understanding the basics, the principles, and the precedents is to get to this moment. It's all about equipping brilliant creative minds with the tools they need to look beyond what already exists and to build something truly new, something totally out of the box. And that's really the final thought I want to leave you with. The smartphone in your pocket, the tablet on your desk. At one point, every single one of them was a radical, out-of-the-box idea that somebody had to architect into existence. They were built on the very same principles we just talked about. So when you look ahead, it makes you wonder, right? What's the next impossible device that's just waiting to be designed?